This lesson is for Math 1 Honors semester course. This lesson comes from Unit 3, Coordinate Geometry and Systems of Linear Equations and Inequalities. We're going to be talking about perimeter, area, and writing and graphing systems. So first of all, what is a system? This is a new vocabulary word. We've been looking at linear equations in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Systems simply means more than one equation. So we'll be looking at, in the beginning, two lines. Let's jump into the lesson. What is the Pythagorean theorem? You may recall a squared plus b squared equals c squared. Write this down in your book. We're going to start with the first triangle. Let's look at it and determine what we have. We have the indication of a right triangle in this corner. So the legs, the two shorter sides, make up the right angle. So we have side A, we'll call 6A. It doesn't matter which one you call A, which leg you call A, which leg you call B. So we'll call the side of length 8 B. Now let's substitute that into the formula. So we're going to have 6 squared plus 8 squared equal c squared. 6 times 6 is 36 plus 8 times 8 is 64. That's going to give us our c squared. Well, what is 36 plus 64? That's 100. All right, so now we're going to take the square root of 100 because 100 is c squared. Take the square root of both sides. The square root of c squared is c, and the square root of 100 is 10. 10 times 10 is 100. So now we've found the length of the hypotenuse. Now let's move on to the second triangle. We have to have an indication that this is a right angle. So let me draw that little square corner here. With that square corner, we can see that 15 and B are the two legs. I've just chosen B to be the missing leg. A is 15, so 15 squared plus B squared equal 17 squared. This time we do have C, the longer side. So go ahead and substitute that into the equation. And then we'll work on solving for B. Okay, 15 times 15. Put that in your calculator. Go ahead and square that. That's 225 plus B squared. We still don't have B, so we've got to write that variable, equal 17 times 17 is 289. Get in the practice of using your calculator, especially Desmos, because that's what you'll be using on your EOC. The more you practice, the more relaxed and confident you'll be when you take your tests. All right, now what we're going to do is we're going to subtract 225 from both sides. So I'm going to line that up where it goes. Save some room. All right, now I'm not going to draw the line. I'm just going to bring down the b squared because 225 minus 225 is 0. So bring down your b squared equal, and then 289 minus 225 is 64. All right, take the square root of both sides. The square root of b squared is going to be b, and the square root of 64 is a perfect square. It's 8 times 8. So the square root of 64 is 8. We found the missing leg, so B is equal to 8. Let's go to the bridge and let's put together some of the things that we've learned. So we have a quadrilateral. Quad means 4, lateral sides. It's labeled A, B, C, D. A trapezoid has 2 sides that are parallel. The other 2 sides are not parallel. All right, 25, side AB is parallel to side DC. So this is a perpendicular height 12, and it's indicated to be a right angle, a 90-degree angle here. These sides are parallel, which would make angle B also a right angle. But we don't know what angle A or angle D are. We just know the length of this slanted side is 15. We want to know the area of the trapezoid. So let's think about that for a minute. There are 2 approaches here. In math, there's often, very often, more than one approach. We'll start with the area of a trapezoid. A trapezoid has 2 bases, has a top, which we can see is 25, and it has a bottom, which we cannot see. So we would have to figure out how to find that bottom length. But if we know that bottom length, we simply add base 1, which is typically the bottom, plus base 2, the top, and then take half and multiply it times the height, which we can see is the perpendicular, the vertical height, as 12. We add them together, multiply by the height, and then divide by 2. All right, but I don't know what the length of this bottom is. Another approach would be to use the Pythagorean theorem to create a right triangle on the left side. So we could take this left side and cut off that triangle right here, as long as this is a perpendicular height. Now, if that is a perpendicular height, we've created a rectangle. If we cut this off with that perpendicular line, we have the same measurement. We've created a rectangle and a smaller triangle that we're just going to move aside and look at later. We can find the area of this rectangle because that's going to be length times width, 25 times 12. And if you'll notice, that 12, that height, that opposite side is going to be the same as the height of BC. Also, the top base, the 25AB, we can bring that down to the bottom. It's not going to be the base of the trapezoid, but it's going to be the bottom of that rectangle. Opposite sides are congruent, opposite sides are parallel, and we have 90-degree angles in a rectangle. So simply multiply 25 times 12 to get the area of that rectangle. But we've got to add this triangle onto it. So how do we do that? We're going to use the Pythagorean theorem, because as you can see, I have the hypotenuse and I have one of the legs. So substitute in one of the legs for A or for B. In this case, I'm using it for A. So 12 squared plus B squared, that's going to be that missing bottom part of the bottom leg of the triangle, equals the hypotenuse squared. 12 squared is 144. 144 plus B squared equals 15 squared is 225. Now subtract 144 from both sides. 144 is a constant term, so it cannot be subtracted from or combined with anything that is not a constant number, a constant term. All right, so 144 on the left minus 144 is 0. So all we're left with is B squared. We're going to bring that down. Equal, and then take your calculator, 225 minus 144 gives us 81. Take the square root of both sides, so B is equal to 9. So now we know the length of that missing leg. All right, now to find the area of a triangle the area of a triangle is the base times the height. Because this is a right triangle, the legs are going to be the base and the height. So 9 times 12 divided by 2. All right, 9 times 12, base times height, divided by 2 is 108 divided by 2. 9 times 12 is 108. Let's divide that by 2 and we get 54. So now we know the area of, let me write that in, the triangle. Area of the triangle is 54. And what did we say the area of this rectangle is? What's 25 times 12? Length times width. 25 times 12 is 300. So we simply add 300 plus 54 to get 354. Now we can find the perimeter. We're going to add 25 plus 12. Let's go all the way around in any order, but don't miss any of those numbers. 25 plus 12 plus 25 plus 15 plus 9. Add all those up, and you should get 86. Let's go to activity 1 on page 72. Below we have a picture of two triangles with vertices on coordinate grid points. We want to know the perimeters of triangle ABC and triangle PQR. Alright, so the first thing that I do, we just have the pictures of the triangles, is I go ahead and look at the points that are labeled and I write down carefully what those coordinates are. Remember, in the x direction, we're going to go vertically. We're going to start at 0 and count backward. 1, 2, 3, 4, 5. Look in your book on page 72. It's going to be a lot clearer than this slide. So go back to -5 and up to +3. So coordinate A is -5, 3. Now here's a hint for you. I like to stack the points on top of each other. So I'm going to put point B underneath point A. And this is, count to the right now, 1, 2, 3, 4, 5, 6, 7, and go up 8 for point B. 7, 8. Horizontal direction, then vertical direction. For point C, I'm going to go across to 7, and then up to 3. So that coordinate is 7, 3. Now since we're labeling the points and we're stacking them, I'm going to go ahead and label the points on that second triangle. So I'm going to go in alphabetical order. P, Q, R. Point P is 1, 2, 3, 3 to the right, and now we're going to go down. 1, 2, 3, 4, 5. So that's a -5. Point Q, I'm going to go to the left, so that's a negative direction. 1, 2, 3, 4, -4. And down 2, so that's -4, -2. And then, oops, I think I did this wrong. Okay, point P is actually 3, go down 1, 2, 3, 4, 5. I did that right. Point R is to the right 1, 2, 3, and down 2. I thought maybe I had got those mixed up. So check and double check, get those coordinates written down correctly. And then we're simply going to find the distance between those 2 points. I can count the vertical and horizontal distances. Okay, so let me go ahead and count and write those. All right, BC is 1, 2, 3, 4, 5. Okay, AC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can use the Pythagorean theorem to find the distance. A squared, 12 squared is 144, 12 times 12, plus B squared. B, I'm using 5 for B. 5 times 5 is 25. Okay, add those together and you'll get c squared. So 144 plus 25 is 169. That's going to be c squared. So take the square root of 169 and you'll have c. The square root of 169 is 13. Now add those three numbers together. 12 plus 13 plus 5 for the area of ABC. And that's going to be 30. 12 plus 5 is 17, plus 13 is 30. All right, we're going to do the same thing. Use the Pythagorean theorem. I'm going to highlight this time. Okay, QR, let's count. 1, 2, 3, 4, 5, 6, 7 units. So it's going to be 7 units. Okay, now we're going to count the length of RP. So we're going down. My eraser on. We're going down. We're not thinking when we're calculating distance. We don't need to consider whether it's positive or negative. We just want to know how long it is. So if I count, that's 3 units. So a squared, that's going to be 7 times 7. That's going to be 49. Plus 3 times 3, b squared. 3 times 3 is 9. Add those together. 9 plus 9 is 18. That's 58. And that's going to be c squared. So we have to take the square root of 58 to undo that square on c to get the length. And length is always positive, so we're just going to take the positive number. Right, so that's going to be approximately 7.2. Square root of 58. Put that in your calculator. Put 58, take the square root and round it to approximately to the hundredths place, and I get 7.62. It's an approximation, so we're going to use those squiggly lines, approximately. If we want to know the exact answer, we keep the number under the radical. All right, so another way to look at this is using the distance formula. So I want you to stop and write this down in your book. Distance equals the square root of x squared, x sub 2. And x sub 2 just means the second point that we're looking at. Kind of like when we did slope. We found the difference of the y's over the difference of the x's. This is going to be the distance formula. It doesn't matter whether you start with y's or x's in the distance formula. You're just going to find the difference in the x's, the difference in the y's, and you're going to square that, add it together, and find the square root. It's using the Pythagorean theorem to come up with this formula to find the distance. So you don't have to have a right triangle to find the distance between 2 points. That's what we need to get at. So make sure that you're writing this formula down so that we can use that moving forward. All right, so I've got the slope formula and I have the distance formula. We have 4 points, A, B, C, D. That's given. So what I'm going to do is I'm going to organize that information. Point A is 1, 0. I'm going to stack them on top of each other. And you could also write those points on the graph, but I like to organize them this way. All right, now we have the coordinates labeled. We have the points stacked on top of each other. All right, now we have everything organized and labeled. So what I'm going to do, I'm just going to talk you through this, is we can use the Pythagorean theorem a squared plus b squared equals c squared. So if we make a right triangle here, this is going to be of length 1, 2, 3, 4 for that longer leg, and 2 for the shorter leg. If we make that triangle all the way around that right triangle, it'll be 4 separate right triangles, all the way around that square, we'll notice that these distances are the same. 4 and 2, 2 and 4, 4, oops, that kind of went wild, 4 and 2. So a squared plus b squared equals c squared means all of these sides are going to be congruent. Okay, now we can find the slope. So this is why stacking them makes it easier for me, because it gets confusing. All right, I want to find the slope of AB. So let's look at A and B. The difference of our y's, I always start with the second point. -2 minus, go to the first point, 0. And now we're going to find the difference of our x's. Go back to the point that you started with point B, 5 minus 1. And that will give us the slope. -2 minus 0 is -2, and 5 minus 1 is -4. Oh, sorry, +4. Don't want to rush because I'll get my signs wrong. All right, one negative when we divide gives us a negative, and we can divide 2 and 4 by 2, so it's going to be negative. 2 divided by 2 is 1, 4 divided by 2 is 2. So for side AB, the slope is -1/2. Let me go to the opposite side, because if these are the same, -1/2, we can say that these are parallel. All right, so DC, these 2 points. Okay, so I'm going to go 4 minus 2, start with your y's first, over 3 minus 7. On the top, 4 minus 2 is +2. On the bottom, 3 minus 7 is -4. Okay, same thing as we had up here, except the negative is with the 4, but it doesn't matter. Just think about it. When you're dividing and you have one negative, or multiplying and you have one negative, opposite signs give you a negative. We're going to divide 2 and 4, because they're both even, by the number 2. And we get -1/2. So those are indeed parallel. They're the same. Now the trick is to prove that the consecutive sides, AB and BC, are perpendicular. We would flip this upside down and write it as 2 over 1, which is just 2. And we would change that negative to a positive. So we need to have opposite reciprocals as slopes. So we're looking for a +2. Now you can see that this line BC is slanting to the right, so it should be positive. And AB, notice it slants to the left, as does CD. So those are indeed negative. That's just a second check to make sure that we got the positive and the negative sign correct. All right, so let's actually calculate the slope between C and B. So C and B, I'm going to start with my second number, 2, and I'm going to subtract -2. So 2 take away -2. 2 negatives make a positive. That's going to be my rise. Y's, rise, over run. And remember, we're looking at CB. That's why I changed the color so I wouldn't forget. Go back to the x's. 7 take away 5. All right, 2 plus 2 is 4. That's going to be my rise. And my run, we took our x values and found the difference. We got 7 minus 5 is 5, 6, 7, 2. And 4 divided by 2 is indeed 2. So we have a slope of 2 here. So the consecutive sides have slopes that are negative inverses, or another way to say that is opposite reciprocals. Getting tongue-tied there. All right, one more test, AD. So we're going to go from A to D. Start with the second point, 4 minus 0. Really doesn't matter what you start with, as long as when you go to your difference in your x's, you start with the same point that you started with, calculating the difference in your y's. Okay, and then 3 minus 1 is 2, and that simplifies to 4 over 2, and that reduces to 2. All right, so this slope is 2. So we plotted the points, we connected the points, we found the slopes, and we found the length of the sides. Now, the side lengths, did we find the side lengths? We didn't find the side lengths, we just talked through it because we have the same a squared and b squared. But a squared, let's go ahead and calculate that. 4 squared plus 2 squared. 4 times 4 is 16. 2 times 2 is 4. 16 plus 4 is 20. And you have to find the square root of 20 to find the hypotenuse. The square root of 20, if you want an approximation, put it in your calculator. If you want an exact answer, you leave it the square root of 20. All right, but it's approximately 4.47. Activity 2, we have a quadrilateral K, L, M, N, and we're given the coordinates -5, -1, -1, -4, 5, 4, and 1, 7. So what we need to do is we need to first of all draw it. So we can do the same thing that we did earlier, is we can use the Pythagorean theorem, or you can use the distance formula. Let's use the Pythagorean theorem here. We have a length 1, 2, 3, 4, and this time the other leg is 3. So 4 squared, 4 times 4, plus b squared, 3 times 3, 16 plus 9 is 25, and take the square root to find the length of the hypotenuse. So the square root of 25 is going to be 5. All right, now I'm going to use the distance formula to find the length of this side, just a different way to do it without drawing that right triangle. I'm going to go ahead and erase that because sometimes we don't have right angles, so we can't make a right triangle. So the distance formula, we simply take the difference of our x's, subtract those, square them. So let me label K and L. So we're looking at these 2 points. And you can start with your y's or your x's, it doesn't matter. Just take the difference of your x's, so that's going to be -5 minus 1 minus -1. Do this slowly and carefully. Those negatives will confuse you. Once we find the difference, we're going to square it. We're going to add it to the difference of our y's. -1 minus -4. And then we're going to square that. All right, remember 2 negatives, you take away the negative, it becomes positive. So -5 plus 1 is -4. We're going to square that. This is still all underneath the radical. And then when we take away -4, it becomes +4. So -1 plus +4 is 3. And we're going to square that. So -4 squared, let me go up here and write this out. -4 squared is -4 times -4. No matter what sign you have when you square a number, it's going to become a positive, because 2 negatives when you multiply together give you a positive. plus, now we're going to add 3 times 3, which is 9, and 16 plus 9 is 25, so we're taking the square root of 25, which gives us 5. So now we have two ways to look at calculating the distance between those 2 points. If you can make a right triangle, you can use the Pythagorean theorem. If you can't, and on a coordinate plane, you should always be able to make that right triangle. But we don't always have the points in a location that we can see clearly. So having this distance formula, distance equals, subtract your y values, subtract your x values, square them, add them together, take the square root, you're still going to get the distance between those 2 points. Alright, so the square root of 25 is 5. Okay, we found those lengths. Let's find the length between M and L. Alright, this time I'm going between M and L. Okay, so the distance between M and L, let's put the distance formula into practice. I can start with my x's or my y's in the distance formula. So let's start with the y's this time. 4 minus negative 4, and then we're going to square that. We're going to add that to 5 minus negative 1. And then we're going to square that, and we're going to take the square root of all of that. 2 negatives together make a positive. 4 plus 4 is 8. And we're going to square that, remember? So 8 squared is 8 times 8. Let's simplify this binomial. 2 negatives together, take away a negative, you get a positive. So 5 plus 1 is 6. We're going to square that. 6 times 6 is 36. And 8 times 8 is 64. We've got to add those together and take the square root. 64 plus 36 is 100. And the square root of 100 is 10. 10 times 10 is 100. Now let's use the Pythagorean theorem since we have these points in a location that I can see clearly. I'm going to count up, rise, and then run. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. And then 1, 2, 3, 4, 5. We've got 5 here. Is it 5? Nope, I didn't go over. 6. Okay, so you can see a squared, 8 squared, plus b squared is equal to c squared, which is 10. Alright, we found the distance of each side, so opposite sides are congruent. Now we need to find the slope of each side. Okay, so slope is change in y over change in x. So let's go from, let's use some organization here, that's why I stack them. Okay, let's go from k to n. I'm going to look at this side first. So k to n, okay, take the difference in the y's, always start with the second one. So 7 minus, go to the first point, negative 1, over, go back to where you started. I'm going to draw an arrow so I can show you what direction I'm going in. So start with 1 minus negative 5. We started with 7 for the y's, start with 1 for the x's. Alright, 2 negatives together make a positive. 2 negatives together make a positive. So 7 plus 1 is 8, and 5 plus 1 is 6. Now both of those numbers are divisible by 2, so divide by 2 in the numerator and divide by 2 in the denominator. 8 divided by 2 is 4, and 6 divided by 2 is 3. Let me change colors here. A little bit bigger. Alright, so 8 divided by 2 is 4. So the slope here is 4/3. In order to prove that this is a rectangle, we need a right angle here. For these two lines to be perpendicular, this slope needs to be the opposite, in other words, a negative, and then flip this upside down 3/4. Alright, so I'm saying this is what this should be. So let's go to NM. And I'm going to draw an arrow, show you what direction I'm going. I'm going to start with 7, take away 4, over 1, take away 5. 7 minus 4 is 3. I'm starting to see that flip. And 1 take away 5 is negative 4. And a positive divided by a negative is negative 3/4. So I do indeed have a perpendicular, those two perpendicular line segments. Now let's find the slope of ML. Same thing, start with your y's. 4 take away negative 4 is 8. I'm not going to show the work this time, I'm just going to kind of talk you through it. And then 5 take away negative 1 is, when you take away a negative, you're going to be adding a positive, so that's going to be 6. And then you simplify that and you get 4/3, which is what the opposite side is. Now one last segment, KL, negative 4 minus a negative 1 is negative 4. When you subtract a negative, you're adding a positive, over negative 1 minus negative 5. So we'll be adding, we're taking away that negative 5, adding 5. So that simplifies to negative 3/4, which is what the opposite side, opposite slope is. So we can see that opposite sides are parallel, consecutive sides are perpendicular. So this is a rectangle. This quadrilateral is a rectangle. Go through your summary and glossary starting on page 74. Highlight the vocabulary. Make sure that you pay attention to what it's telling you. One thing that's important is don't go by pictures, go by what it gives you mathematically to prove that you have a rectangle, a square, what's going on with the length of the sides, what's going on with the slope, to determine if you have parallel or perpendicular lines, because pictures can be deceiving. Okay, they're just a help for us, but they're not, we need to use the math to prove it. Alright, to be a square, we would have to have all the sides the same length. So you need to be going through this, reading, highlighting what's important, and then looking at those formulas and what's happening. Remember, we've been using the Pythagorean theorem a lot, and if you get stuck without a formula, go back to what you know, and you should know the Pythagorean theorem. Alright, this talks about what slopes of lines mean, parallel and perpendicular. How to find the slope. That's going to be change in y over change in x. So you need to have 2 points. You can find the difference of the y's over the difference of the x's. Alright, so go through all of that carefully to study and to get ready for your test, which is coming up. Not this week, but soon. And the distance formula, make sure that you have that highlighted, written down to refer back to. Now when you're dealing with small numbers, you never need to use the distance formula as long as you can remember the Pythagorean theorem. But the distance formula will come up in more advanced courses, so it's a good habit to practice it now. Go on to lesson 8. We have a problem. Let me read through it once to get an idea, and we'll go back and then we'll highlight the important information. Andre and Noah started tracking their savings at the same time. Andre started with $15 and deposits $5 per week. Noah started with $2.50 and deposits $7.50 per week. The graph of Noah's savings is given, and his equation is y equals 7.5x plus 2.5, where x represents the number of weeks and y represents his savings. All right, so I got a general idea. Now I'm going to go back and highlight information. All right, it's not asking a question. I usually go first to what the question is. We're going to write an equation for Andre's savings. I guess I could interpret that as equation and graph it alongside Noah's. So what we need to do is we need to highlight what the problem's giving us. All right. Andre started with $15 and he deposits $5 per week. Per typically means multiply. We don't know how many weeks. That can vary. That's going to be our variable. I would call it W. On the graph, I would call it X because time is always our X value. Week, time. And we're counting by ones. 1 week, 2 weeks, 3 weeks, 4 weeks, and so forth. All right, let me get a different color highlighter. That's Andre. Let's see what Noah's is. Noah's started with $2.50 and deposits $7.50 per week. Now we have the graph of Noah's savings and we have his equation. So let's look at that graph. Okay, it should start, the starting point is where it's going to cross the y-axis. So it's going to cross at 250. So in your book, make sure you've got the information, the important information highlighted, not everything. Just highlight, make sure you can transfer this to your graph. So it starts at 250 and it's going to go up $7.50 per week. So we go up $7.50 and go over 1. Up $7.50 and go over 1. That's kind of hard to calculate, but that's what the line is doing. It's kind of hard to graph, but that's what it's doing. All right, now this, I'm stumbling because I don't know how to explain this, but this is Noah's because he started at 250. The y-intercept is 250. Okay, I need to write the equation for Andre's. I'm going to switch to a different color. So Andre started at $5, so we're going to start right up here. I'm going to put that y-intercept at 5. So let me draw that point here, and let me write the equation. All right, so it's going to be y equal, you started at 15, so that's going to be our plus b, plus 15. So y is equal to $5 per week. Normally I'd use W, but I'm going to use an X to indicate weeks, because that's how it is on my graph. The input is weeks. So y equals $5 per week plus the $15 that we started with. Okay, so I'd start with 5. I'm sorry, I'd start with 15. Did I get that right? Did that wrong. Start with 15, so I'm going to start up here. And then I'm going to rise 5 and run 1. Now this is in terms of 20, 25. Okay, this goes up by 5. So 5, 1. So if I go up, I'm going up 5 over 1. This is a little easier to graph. Up 5 over 1, up 5 over 1, up 5 over 1. So they're going to intersect right here. I'm going to connect the dots. This is harder for me to do. Okay, with a line, and you can see that they intersect right there. Okay. They intersect at point 1, 2, 3, 4, 5 and up 40. Alright, so there's your equation. This is where it crosses the y-axis, the y-intercept. And this is the rate of change. We're going up 5 and over 1, our slope. What does the intersection point mean in this situation? So you've got to know that x is your weeks on the x-axis. On the y-axis, dollars, your savings, is going to be your y. So what that means is in 5 weeks, both Noah, because they intersect, and Andre have $40 in their savings account. That's when they'll have the same amount of money, and it's going to be at 5 weeks, and the amount's going to be 40. So go to Desmos, and we want to graph both equations. Okay, so we've got, write this down in your book, y equals 5x plus 15. I'm writing it down so I can graph it. And Noah's is y equals 7.5x plus 2.5. Alright, let's go over to Desmos. We're going to start by putting in the first equation, y equal 5x plus 15. And then I'll enter my second equation, y equals 7.5x plus 2.5. It's showing up as, mine's showing up as a green and a blue line, so I can differentiate between the two lines. I'm going to need to zoom in or zoom out, and then I can move this around. But the quickest way is to adjust with the wrench my graph settings. Now look at your graph, the first one. I see that it's intersecting the y-axis. The y-intercept is 15. And if I move up a little bit, I can see where they're intersecting here at 40. So I need to go up to at least 45 on the y-axis. So I'm going to click the wrench, and on the y-axis I don't need to go into the negatives, so I'm going to start at 0 and I'm going to go up to 50. And if I want to adjust it even more, I can tell it how to step or how to count. You can see it's going from 10 to 20, 20 to 30, so it's counting by 2, 4, 6, 8, 10 by 2s. You can tell it to step by 1, and then it will, let's just take a look and see what happens. It adjusted it a little bit. Okay, go back from 0 to 50. And count by ones. It's not changing it. I'm not seeing it change. Let's go ahead and go by 2s. All right, let's go to the y-axis. The x-axis. And I can see the x is going out to 2, 4, 6, 8. I know that's counting by ones. Let's go out to 20 on the x-axis. We don't need to go to the left, so I'm going to go from 0 to 20, and I'll count by 1. That y-axis keeps changing. Let's keep those. Separate. Alright, so from 0 to say 45, and we'll count by 2s. And my x-axis changed. Alright, so I'm going to go from 0 to 15. I'm going to step by 1. Okay, so now I see where those lines intersect, and I can click point, as I zoom in, I can see it better, at 540. So that's where Noah and Andre will be equal. At 5 weeks, they both have $40. Took that check mark out. All right, so there's my X and Y axis. All right, we're looking at this problem. We're going to look at this moving forward in this short lesson. First, I'm going to read the problem, and then we're going to highlight what's important and put it together in an equation. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 per pound, and walnuts cost $8 per pound. Diego spent $15 on both ingredients. All right, so let me highlight. We've got raisins and walnuts. Raisins cost $4 per pound. Per means multiply. We don't know the number of pounds. That can vary. So we'll choose a variable for pounds. I'm going to go ahead and call that X for raisins. And then it costs $8 per pound for walnuts. And I'll call that Y. The number of pounds of walnuts is going to be Y. And then we have a constraint. Diego spent exactly $15 on both ingredients. Decide if each pair of values could be a combination of raisins and walnuts. So what we're doing is we're testing to see if 1.5, that's going to be our X, and 1, that's going to be our Y, substituted into the equation gives us a true statement. All right, so let's think about how we would put that together. So raisins is X, the cost is $4 per pound, so 4 times the number of pounds plus let me think here, plus 1 times the number of pounds of walnuts is exactly $15. That's our constraint. So we have 1 for walnuts and 1.5 for raisins. So we're going to substitute those numbers in for X and Y. So 4 times 1.5, use your calculator, plus 1 times 1. I can go ahead and multiply 1 times 1 in my head. That's just 1, should equal to 15. So taking my calculator out, 4 times 1.5 is equal to 6. So is 6 plus 1 equal to 15? And the answer is no. Now we're going to try this out for 1 pound of raisins and 1.5 pounds of walnuts. So remember, the number of pounds of raisins, we're using X. The number of pounds of walnuts, we're using Y. All right, so 4 times 1 plus 1 times 1.5. We're asking if that equals 15. In the previous equation, it was not equal to. 4 times 1 is 4. 1 times 1.5 is 1.5. 4 plus 1.5 is 5.5. That's not equal to 15. So the answer is no here. All right, let's try it again. We're going to try 2 more sets. 2.25 pounds of raisins times X, and raisins cost, I'm doing this wrong, I substituted an X already, so raisins cost $4 per pound plus 0.75, and the cost of walnuts is $8. So we're going to multiply those numbers together. 2.25 times 4 is equal to 9, plus, that looks like an F, but that's a plus, 0.75. Do you know what 0.75 is as a fraction? That's 3/4 of 8 is equal to 6. And 9 plus 6 does equal to 15. So we can answer yes for this question. Okay, now we're going to try one more. Raisins, the number of pounds is 3.5. We're going to substitute that in for X. Multiply it by 4, because 4 is the dollar amount for each pound. Add that to 1 pound of walnuts. Substitute 1 in for Y, and multiply times 8, because that's the cost per pound of walnuts. And let's see if we get 15. 15 is our constraint. So 3.5 times 4 is 14, plus 8 times 1 is 8. 14 plus 8 is not equal to 15. That's equal to 22. So that's going to be a no. All right, using that same situation, write an equation to represent this constraint. Let X be the pounds of raisins and Y be the pounds of walnuts. So you've got to identify, we've already highlighted important information, read through and understood the problem. So we've been using X for raisins, just like they ask us to, and Y for walnuts, so we can write that equation. $4 times the amount of raisins, X, plus $8 times the amount of walnuts, Y, equals exactly 15. So use this equation, put it into Desmos, and we're going to graph it. 4x plus 8y equals 15. All right, you don't need to solve for y. You can just put it in just like it is. 4x plus 8y equals 15. It will graph it for you. So I can click here and see that my y-intercept is 1.875. And my x-intercept is 3.750. Let's interpret what that means. What that means is, on the y-intercept, if 0, remember x is the number of pounds of raisins, if we buy 0 pounds of raisins, we can buy 1 pound 875 thousandths, or 0.875 pounds, 1.875 pounds of walnuts, and that will equal exactly $15. Now in contrast, if we don't buy any walnuts, but we buy 3.75 pounds of raisins, we'll spend exactly $15. And you can go to any point on this line. You can just click, and it tells you the combinations that will work. 3 pounds of raisins and 0.375 pounds of walnuts will equal exactly $15. Anywhere you click tells you what the combination is to stay within that constraint. So your graph should look something like this. Now we can also make a table with that same situation. We can make 2 columns. This would be our x, raisins is our x, walnuts is our y, number of pounds of each. So if raisins is 0, walnuts would be 1.875. Looking at our graph, that's what our y-intercept is. When x is 0, what is y? All right, looking at that graph at 0.25 or a quarter of pounds of raisins, we'll see that we can purchase 1.75 pounds of walnuts. So again, we can move up and down that line and we can find that combination of numbers, or we can substitute into the equation 0.25 for x and solve for y. So if we have 1 pound of raisins, we can find that on the graph or substitute it in for x and solve for y and get 1.375. Continue doing this, going between the graph and the equation. Use Desmos to check your work. Use algebra to solve the equation. So you can find where a combination of pounds of raisins and pounds of walnuts gives you exactly $15 spent. Now here's a new piece of information. Diego bought a total of 2 pounds of raisins and walnuts combined. Write an equation that represents this constraint. Let x be the pounds of raisins and y be the pounds of walnuts. X plus y equals 2. So this is a different scenario. The constraint is 2 pounds. Use graphing technology to graph the equation. So again, you can just type in x plus y equals 2 into Desmos, make adjustments, and you can see what the y-intercept is and what the x-intercept is. You can also use a table. You can plug that each of these values, whatever value is given, the x or the y, and solve for the missing variable. Practice that in your workbook using the calculator. But notice that when you get to 3 pounds of raisins, you get -1. And that's not possible because if you remember, the constraint is 2 pounds of raisins and walnuts combined. So we went over with 3 pounds of raisins. That's why we got a negative number for y. Diego spent $15 and bought exactly 2 pounds of raisins and walnuts. How many pounds of each did he buy? Explain or show how you know. 0.25 pounds of raisins and 1.75 of walnuts. It's going to be the point of intersection between those two equations. So remember what those two equations were. X plus y equals 2. And then that first equation, 4x plus 8y equals 15. So this is leading us into the next lesson, where we can write two equations and find where they intersect. Here's another example. We're not going to go through it because of time's sake. This is a short lesson, so go into the summary and glossary, read through the lesson debrief. Remember, the new vocabulary term is system of equations. System means more than one. So we have the one equation here, the second one here. We want to graph those linear equations, and where they intersect is the solution to the equation. Go ahead and read through, and your assignment for Friday is page 77, 1, 3, 4, and 8, page 89, 1, 2, 3, 4, and 8. So practice those, have them done.